Hello everybody, and welcome to your first tutorial in this Attitude Dynamics class. So in this tutorial, we're gonna see how Simulink works, and like the first tutorial is gonna be really the basis, just what is Simulink, since apparently none of you has used the code like this type of software to solve ODEs. And I really advise you to start using right after, especially like even if you see that in the first homework, the first coding homework, the solution is really easy, and you're like, yeah, I know how to do this problem only just using MATLAB's function and everything. They're easy also because it's gonna be easy indeed to creating in Simulink, and so that you can get used to it. And then the second part of the class, when the problems become a bit harder, you can just already know how to use this software and everything. And really the advice is so because at the end of the class, when you have to submit your final project, you're gonna find out that if you have done everything by Simulink, at the end, each homework is basically a puzzle piece of what your partner project consists of. And at the end, you just have to put everything together. While on the other hand, you will have to code a new MATLAB, usually even more function from zero. And that's, of course, takes too much time. And indeed, start using Simulink for the beginning can be really time saving, and you find out that the project actually is not that demanding, since every time you basically do a single block. So let's start to see how Simulink works. Here we go. Let's put this here. And here, once you download MATLAB, be sure to download every package of it. Like actually not every package, but all the Simulink packages, so you are good with it. And here on the home page of MATLAB, you see Simulink. I'm gonna click it, and it's gonna initialize, and it's gonna open this page here. Here, you can either start a blank project, or usually since homeworks are not that demanding, you can just start with a blank model. And that's what I'm gonna click. Let's let the program load, and here we have. Here we are with a completely blank model. And let's see what we're seeing here. Except for like the common like saving and adding or other models, we have here this number that it creates indicates the time of your simulation. Since you're gonna simulate a model that's gonna behave in time, a dynamical model, this number here, which is 10, is gonna indicate you how long, how many seconds that the simulation is gonna run. Now the model is blank, and here we have the library. I'm gonna click it, and the library is gonna pop out. Here under Simulink, which is basically all the boxes we're gonna use, there are plenty, as depending on how many tools you have downloaded from MATLAB. We're gonna basically use only the basic ones for the whole class. And as you can see, we have the commonly used blocks, and we have we have sinks that like usually when the signal ends, like stop simulation, outputs, scopes, which is basically a plot, and we have sources. And what you can do in this case, you keep your library on the side, and you can drag the block you wanna and leave it in the model. Here we go. So here we have a constant. You can put it whatever you wanna. You double click on it, and you decide the value. Let's say 2. Apply. Okay. Now, this block just generates a number, which is number 2 in this case, and it's constant in time. Therefore, when I wanted to work with it, I can go, for example, here on gain. Gain is basically just a multiplication, and let's say we have a gain of 5. Now, each arrow basically connects the input to the output. And therefore, this line now is bringing 2 to the 5. If you already know which block you're gonna use and you don't want to go to the library, find it, and drag it in the code, as soon as you're gonna get a little bit more knowledge on different blocks, you can just click on the blank code and type the name of the block you wanna. In this case, I'm looking for scope. As you can see, under is gonna tell you where you can find it, like Simulink under sinks. However, you click it, one number of bars is sufficient for us. We're gonna put it here and connect it. So this is a really simple system. We have a constant in time, 2. In time, it's gonna be multiplied by 5, and here we're gonna see the output signal. Now, when we press run, we're gonna see here the code compiling, and depending on how much heavy your work is, it's gonna take longer to compile. And in the other final project can even ask for like 2 to 3 minutes. And then we're gonna see the output. See, here it's compiling really fast, and yes, done. Double click on scope, and you will see that the output is a signal with value 10, since it's 2 times 5. Really easy. Now, let's say that I want something a little bit more complicated. Let's do something like a sine wave. Here on Simulink sources, we can find a sine wave, and it's gonna ask for the amplitude. Let's say 3. What I can change in sine wave is also, when I open the menu, the bias, the frequency, let's say now 2 rads per second, and the phase, and technically even the sample time, but it's fine. Just put 2 as frequency. Now we're gonna see that when I run this code, this is the output, which is a sound wave, and it starts at 0, at time 0, with amplitude 3. Really easy. Now, each line is moving a scalar, but that's just because of the situation. Each line usually moves a vector, and you can work with vectors. You can stack them and divide them using 2 different codes, 2 different blocks that are really helpful. Therefore, let's look at max. The max block is going to ask for the number of inputs. In this case, 2 is fine. What I'm going to do now, I'm going to keep only 1 scope, and then I'm going to put the max here. Let's say here that again it's 1.5. Just I'm gonna run it. Indeed, here we can see that the vector as being stacked, and we see as a scope that we have 2 different graphs overlapped one over the other. Indeed, it is presenting the true and the sine wave. What to do now? Let's create another sine wave. Let's say with amplitude still 3, and I want it to be frequency 2. And let's say this is a cosine, so with a phase, apply. Okay. Just double check it. Here we go. Indeed, we start with the maximum, and then we go down. This is our cosine wave with frequency 2 again. What I'm going to do now, I'm going to integrate this cosine. And so I'm going to look for an integrator. Here, the integrator block is going to ask me for the initial condition, since Simulink wants to know where he has to start. And when it integrates, it cannot, like, it doesn't add a plus C plus constant. It actually wants to know the constant. So let's say that the initial condition is 0. And let's put it here. Actually, let's connect it again. Let's say with another max. Let's run it. And here we go. As we can see, in yellow, we have the original cosine wave that we created with amplitude 3 and frequency 2. And in blue, it's the second output, the one that gets integrated. The initial condition is being expected here in 0 times 0. And indeed, if due to the integration, we take the frequency half, so it's like frequency 2 is 1/2. Indeed, the amplitude is 3/2 over here. Therefore, it works. And that's basically what Simulink is all about, because it's really easy to integrate and solve for the ease in time. And like conceptually, I know it's really easy. Like I can see something down, like you always have to, you can also write like I have x dot on the left, x dot, you can add an annotation. Okay. X dot here, and I have x, add annotation x here. Writing annotation is like commenting your code. It helps a lot, and mostly it helps me grade your homework. And usually order is really important, because now, yeah, we only have really few blocks, but usually it's like, and even the final project is going to be so many that you have to group them into different bigger blocks just to have another. And usually it's coding, so there's going to be bugging when you have to debug your code. Indeed, I want to show you how to do that. Let's say that you want to these two blocks are too many. Like you want this to, let's say I have another gain here, maybe like a gain 3, and I'll put it here, and this is too complicated, or like it starts to be too heavy. You want this as a single block because it's easier, like really easy to follow. You can select it and go to here and create a subsystem. Bam. As you see, your system that you highlighted has become a single block, which is easy to it's really easy to follow. You can click it and you see that it's the same. We are seeing here two new elements, which is the in block and the out block. And they're just here to tell you, numbered, which one is the in and which one is the out. Indeed, one going back is the constant, and therefore I can come here and call it, hey, this is my constant k. And this one is my wave. And this output is like the plot. And when I go back, I see that the name I've changed are actually the name of the input and the output, K wave, in the order I selected, K wave and plot. Let's go back in. Of course, like nothing has changed. When I plot it, we can see already that, I'm sorry, that the amplitude now is 3 times 3, which is 9, and that 2 times 1.5, 3 constant signal has been respected. And entering, let's say that I want to add another block. I can do a derivative, for example, here. Just import 1. We're gonna connect it. And now I'm looking for out. I'm sorry for the dog. Is a puppy. The out here, number of parts, 1. And I'm gonna put here a dot, since it's a time derivative. As you can see, is the derivative. The block is like delta u over delta t, where u is how we usually call the input. And here, first of all, as you can see, I selected 1. And what happened? It changed. Now, indeed, if I go back, dot has become up as my first output, and plot now is second. It doesn't change much in this example, in this really easy example, because I'm still gonna use a scope, connect it, and I think I'm connecting the wave. So let's see, let's see also the wave. I can have a max. Let's have a max here. Dot. And let's bring the original wave. Boop. Let's run the code. And here now we can see the original wave here in blue and the derivative as expected, which is 3 times 2, which is when you derive the frequency multiplied, of course. And indeed, like sine is cosine derivative, so everything checks out, everything is correct as expected. And I think I can conclude here the first tutorial. Just as you can see, it's really intuitive. If you don't know something in the first try, you Google it, like you do when you learn how to do anything in coding. That's how most programming is. And just have fun if you can, like go through the Simulink library. It actually is really, you can do anything. It's used a lot also for like simulating temperature on surfaces, simulate dynamical model like controllers, filters. You can do a lot, and just have an idea on it. I hope like in this tutorial at least remember the name of Simulink for the next one. And okay, see you in the next one. Let's go back, stop sharing, and stop recording.